Welcome to Tagat, Kiros.
Thank you, Tigray. Thank you for inviting me. It's really an honor and a pleasure and a privilege. I have followed you for a long time and have admired a lot of your guests and also the interviews that you have conducted. So I'm looking forward to it.
Oh, thank you for your nice words. This is something that we've been meaning to do for a long time. So I'm so excited that you have managed to find the time for us today. I'm sure all of our viewers, I would dare say, are going to enjoy your contribution here. But for people who might not know you, you are Kiros Berhane. You are a researcher at the University of Columbia in the US. You focus on biostatistics. We'll get into what that means a bit later. But maybe why don't you give us a kind of broad outline of what you do now?
Thank you. Yeah, so as you said, I'm Kiros Berhane. I'm currently the chair of the Department of Biostatistics at Columbia University in New York City. For those who are outside of the US, Columbia University is one of the 8 Ivy Leagues in the US, one of the most prominent universities. So I joined this position about 6.5 years ago as the chair of a department. In addition to that position, I'm also co-directing a new center called CARCH, which is Center for Achieving Resilience in Climate and Health. And I do hold other, senior advisory and committee positions in the university. Probably, when it's just two, I serve as a Dean's Advisory Group member for our Dean of the School of Public Health, and I am also a member of the Faculty Advisory Council, which is put together by the provost of the university.
So I think by now our viewers will sense that we're going to focus on academia and research today. So this is a bit of a break from the channel's tradition, because normally we focus on political matters and we invite people who give political commentary, and inevitably one consequence of that is that they divide opinion and all that. That is natural what happens with politics. But today we have somebody who should unite our viewers, I would say. I think everybody should be united in their love for academia, for research, and for science and for technology. So we'll get into these things, Kiros. So what are the, broadly speaking, in layman terms, if that is possible, what are the problems that you grapple with today as a researcher?
Yeah, thank you. Yeah, so my primary field is biostatistics. So that essentially is, you can kind of think of it as a branch of mathematics or applied mathematics, but really a discipline on itself, mainly dealing with collecting, extracting, analyzing, and interpreting information. And, I specifically focus on biostatistics, which means biomedical applications of statistics. So my work straddles the world of applied mathematics, and nowadays also, because of data science, artificial intelligence, a little bit into computer science as well, but really various aspects of public health. In my own research, I focus on what we call environmental biostatistics or environmental health. And my research really is twofold. One is developing new tools for how to extract information from complex data sets or information, pools. And then the other aspect of my research focuses on how to use those tools to answer important societal questions. Just to give you a brief example, currently extreme weather or climate change is actually a big, topic globally. And, the most important questions are how much that has impacted human health and how much that has impacted society in general, and using the statistical or data science tools to answer those important questions. Are we seeing more mortality? Are we seeing more deaths or disease? Are we seeing new disease in areas that never happened before, above and beyond what would have happened naturally? How do we attribute impacts of climate change above and beyond what would have happened if climate change didn't happen, right? So these are very, very complex questions, and unless you have the right tools, your answers are also going to be incomplete in a way. So my work is essentially to try to extract or kind of, tease out valuable signals or information from mountains and mountains of data or information. Yeah, I mean, mathematics, I'm sure everyone who went to school will know it, and it has different levels of complexity. It's essentially a way of making sense of the world through, numbers or kind of algorithmic, formations, basically. So let's say, you know, even questions like, why are we on Earth, and why do we live? Why do we, get sick, and why do we die? Some of us prematurely and some of us later. Those are kind of societal questions. So mathematics essentially translates that to something that could actually use information to tease out, that signal. And it could be what we call very theoretical, in a way, actually really try to make sense of how the world works in conceptual and theoretical frameworks. And when I say applied mathematics, essentially I'm talking about the application of those abstract, knowledge bases into something that's tangible. So, for instance, statistics, which is the science of extracting data and making sense of data or making sense of information, could be thought of as applied mathematics. There are many, many others that we can go to as well. But then, biostatistics, as I said before, which is the life science applications of statistics, could also be thought of as applied mathematics. So that's kind of, in a very, very high level bird's eye view kind of point of view, how I can explain it. I hope I'm being as simple as it could be.
Indeed. Wonderful. So how do we use statistics to make sense of what we observe then?
Yeah, so I think the whole science of statistics is about careful collection of data, careful collection of information that actually is geared and designed to answer important questions. And then once you collect the data in a careful way, how to extract information from that data, and then how to interpret whatever you find. You start with a question. You don't, start with an answer, right? So the scientific question has to be formulated properly, and then that has to be translated into a framework where you can actually try to collect data from a community or a population. It could be multiple countries, or it could be multiple observations from the same individual. And then the data should tell you essentially what the answer is like. So a scientific investigation always starts with a question, but the answer follows the data. And really, statistics is a way of actually trying to be truthful to the data or to the information. In fact, there is a very famous saying, usually attributed to Mark Twain, but I'm not sure whether he said it. They say there is lies, damn lies, and statistics.
I think everybody will recognize that. Yeah.
Exactly. And my answer to that, and when I teach, my students, is there are lies, damn lies, and bad statistics, right? If you really start with an answer and you try to force the data to tell your own answer, your biased answer, that is a very good example of bad statistics. And that's what probably either Mark Twain, whoever said it, actually might have, said statistics. My field and my business is actually to really enable people to tell the truth from the data. So that's actually the good practice of statistics, is to really be truthful to the information that you have and stay loyal to that information and try to arrive at conclusions that actually hopefully will better society from the insights that they provide.
So my understanding is that you specialize in biostatistics, which is a branch of statistics, but that otherwise statistics could be applied to multiple other domains, as you mentioned, to climate change and to study of the environment and all that. And so what are the principles or the underlying principles of statistics that are transferable to all these areas?
Yeah, that's a very good question. So in statistics, there is what we call foundational knowledge. So in other words, there are, core areas of knowledge that you have to know. How do you estimate information, or how do you extract information from a collected data? How do you design, a study? And then you have to go deep into the theoretical foundations of why the answers that you get from using the models or the techniques actually are supposed to give you good or reliable information. So there is what we call bias. So you want to have your answers to be unbiased. So in other words, you don't want your answers to be telling you the wrong, to go in the wrong direction. And the way you calculate the information or you extract the information could actually lead you to bias. There is what we call precision. In other words, you would like to be as sure as possible, in what you estimate. Now, one thing that statistics tells you is you can never be 100% certain. The whole field of statistics is about uncertainty. There is always error in everything that you measure, but statistics actually helps you in trying to minimize that uncertainty as much as possible. So that's what we call the concept of precision. So how do you get unbiased estimates that are as precise as possible? So that training is fundamental, and it permeates, every branch of statistics. And then you go to something like biostatistics, which deals with public health. You can have psychometrics. It deals with psychometry, psychology and things like that. You have financial statistics. Statistics goes to law. Goes to business. Statistics goes to engineering. Any field, any science or branch of science that collects information has to use some variety of statistics. Any research, for that matter, any human investigation has to collect information and has to make sense of the information. So in that sense, actually, there is a famous statistician. His name is John Tukey. He used to be at Princeton. In fact, I had the pleasure of meeting him, but he has passed away several years ago. He says a statistician is someone who gets invited to everyone's backyard. In other words, a statistician could really change, a focus and can apply their, tools to any branch of science. Of course, as you go deeper and deeper and as you become more senior and senior, you try to specialize or tend to specialize to some subfield. And in my case, it's environmental applications, broadly speaking. But, if the interest comes a year or two from now, there is nothing to prevent me from going to another branch of statistics or another domain area of science, because the fundamental underlying tools are actually very similar. And nowadays, I'm sure you'll appreciate this because you come from computer science. There is even more fusion going on in the last 10, 20 years, kind of bringing together computer science, statistics, many facets of mathematics, and information science into what we call now data science or machine learning. And of course, everyone will relate to the term AI or artificial intelligence. There is a very, very deep connection as well, even though that is a field on itself, because it really goes beyond just estimation or making sense of information. It actually tries to mimic human intelligence. But if you look under the hood, the fundamental concepts are actually the foundational knowledge of statistics and computer science and mathematics.
Well, interesting. You say that I come from computer science. Indeed, I do come from cryptography, and there we focus more on theoretical mathematics rather than applied, which was why I was interested to kind of clock the distinction. And maybe later we will talk about the latter point you make, which is that at an abstract level or at a fundamental level, all of these supposedly different subjects are actually the same. There are the same principles at work, and we'll get back to that. But maybe to make a little digression to talk about something that I think all our viewers will recognize, the abuse and how people use or pretend to use statistics. I think this is something that people observe on a daily basis. For example, when politicians make pronouncements or decisions, they always purport that everything they say and do is based on statistical data. And I think one difficulty there is that if you are not somebody who is trained in statistics and all that, it might be difficult to tell whether statistics is being abused or not. Other ways that the average person could use to tell when somebody is pretending to be using statistical data when in fact they are making stuff up?
Yeah, I mean, that's a very, very good question. It's becoming even more important by the day because we seem to be swimming in a lot of information. Every gadget that we wear, every piece of, information that we provide, every click that we make on our phones is actually transferring data and collecting data. So there is this kind of infusion of deluge of data nowadays that's actually making things even more important and more difficult. But even before this big data era, people have always used what they think or what they pretend to be reliable information, either by distorting what the data is trying to tell them or by telling only a subset of the data that suits their purpose, right? So most times, actually, it's very, very difficult for the reader or the layperson or the listener to decipher whether someone is telling the truth or not, right? But good practice would be to really dig into what the reasons or what the rationale behind those pronouncements are. So I think asking questions and trying to get, yes, you're telling us this, but where is the evidence? And where do you have your information from? And have you looked into this? Have you looked into that? And, those kind of probing actually will easily poke holes into the lies. And you can easily tell whether there is inconsistency in the narrative that you're being fed. But that said, I think the onus is actually on, in the case of politicians, actually, journalists, for instance, well-informed journalists would really be in the know because they have, access to information to really probe and find out whether people are being fed the right piece of information. And on all of us, especially on the scientific field, when we publish, findings, when we try to write scientific papers, I think integrity and reproducibility, this is a new concept. In other words, what you and I actually come up with, someone else independently has to be able to verify it. So a single piece of information by itself is not evidence, but it has to be corroborated and it has to be justified or replicated by others independently or objectively. So I think that consistency of findings or consistency of narratives is actually extremely important. Now, I'm not sure whether that's going to be a follow-up question for you, but with the advent of big data, the biggest challenge that we have with all this new technology, and especially with the advent of AI now, is, are we really treating both originators, the owners, and the ultimate users of data fairly? Is data being collected in a consistent and fair manner on everyone, or are important segments of population being ignored in the development of these new big models, predictive models, and therefore decisions are being made in the absence of information from big segments of the population? So that's actually creating what we call algorithmic fairness issues in the way that, for instance, very simple, just to relate to our listeners, facial recognition in terms of, criminal profiles. They use actually machine learning and AI tools, but the profiling itself and who is likely to be a criminal or who is likely to commit certain acts could be based on very faulty input information. And the predictive models that, police stations or governments are going to use are going to be based on faulty input data to begin with. And therefore, the decision that they make, even aside from their own personal biases, is going to be guided by a very, very faulty tool. So that actually creates or propagates or amplifies societal biases and societal unfairness because of these new tools. Because people tend to think actually, just because we have sophisticated gadgets, just because we have a lot of data, we are actually getting closer to the truth. But in reality, in fact, we may be getting to something that may be further from the truth, or is truth to some segment of the population, but completely unrelated to other segments of the population. Now, you can take that to the global level. I mean, one of the biggest things actually that I'm very interested in my current research and activities is what we call this epistemic justice. In other words, fairness and equity in how knowledge is both created, validated, and used, in what we call information-driven systems. So we have the global north and we have the global south. And let me take you to climate change, for instance, as one of my areas of interest. There are a lot of global prediction models in terms of what, the world will look like, 10 years from now, 20 years from now. And there are predictions in terms of, how the environment or the ecosystem is going to be affected. Now, very, very important papers that are written in this topic, if you look at the global map of the data, there is practically no data, no input from Africa, from sub-Saharan Africa especially. When you go to Africa, maybe there is a little bit in South Africa, maybe a little bit in the north, the northern part, apart from the sub-Saharan Africa, and very sporadic and low quality information from other parts of Africa. So it's almost like a, dark spot or empty spot. When you go to North America or to Europe or to Asia, there is high density of information. Latin America, kind of in between. But this is the input data that the global models are using to predict what will happen 20 years from now, 50 years from now. So maybe that's the best we can do right now, given the lack of information. But we have to take everything that comes from that model with a grain of salt. The problem is once the prediction model is done, no one is looking back in terms of where the information came from. And therefore, all the decisions, all the funding, kind of scenarios that are put together are based on completely absent information to the part of the world that's actually heavily impacted. So, one of the things that we're trying to do, I have some projects in Africa and many others are trying to do the same thing, is to really make sure that we collect as much primary data as possible from these data scarce, areas, so that, future models could actually, use those information, those pieces of information in order to make the right prediction for these, what we call vulnerable populations, because they are the most affected by climate change, and yet they may not be the most thought of, in the modeling scheme, not out of malice, but just out of lack of information. But you have to pay attention to that. This is kind of where the state of the world is right now. So I think I digressed in my answer from the use of good use or bad use of statistics, but just wanted to amplify that we are actually getting into dangerous territory now because of this huge deluge of data and very sophisticated techniques. If we don't pay attention, I think where we end up actually could be really dangerous for a big segment of the population, of the world population.
I think it was a welcome digression, Kiros, because you took us into an interesting territory when you talk about epistemic justice and big data. Not least because our listeners are Africans, Tigrayans, Ethiopians, but also there is a philosophical discussion to be had about that as well, about who gets to collect data, whose data do we use, how is AI being developed, and how do we bridge that serious gap in terms of what data the whole thing is being built upon. So maybe to make sure that everybody understands what we are talking about, why don't we begin with you telling us what you mean when you say, I mean, this is a term that a lot of people will have heard, but big data, for instance, just tell us what that means.
Yeah, so big data is essentially, something that has been happening for the last few decades now. People are collecting information at unprecedented levels. Let's take, our phones, for instance. We have smartphones now. They collect huge amount of data. Every click we make, every call we make, every step we take, all that is collecting information. We have satellites, that are in the sky trying to collect, purposely for health reasons or for environment reasons, but for other purposes as well. We are collecting a lot of what we call biomarkers. In other words, in the past, someone comes, he takes your blood pressure or, takes their, your blood, and then they try to do some lab analysis. But what used to be like only 3 or 4 indicators of whether your high blood pressure is high or you have diabetes and things like that, nowadays, actually, people are collecting hundreds and thousands of what we call biomarkers from each individual, from every piece of blood. And on any sphere, on finances, on, kind of, people's movements, everywhere, actually, the dimension of data that we're collecting, both in terms of volume, but also in terms of types of information, has just exploded because of technology. So that's essentially what, we mean by big data. In the past, actually, a lot of my studies when I was undergraduate and even when in the graduate school, the whole point was about how to make the most reliable inference or conclusion based on small amount of data, because data were very expensive to collect, right? Nowadays, that's almost a non-issue, right? Because except in very few cases where it's still very expensive, both in terms of time and resources to collect information, in many places, collecting information is not the problem, right? You will have a lot of data. Now, the big challenge is essentially whether what we call the signal, in other words, the useful information, compared to the noise, which is a lot of information but may not be informative. Proportionally, what we call the noise information is actually exploding but the signal is not growing as much. So think of like a high stack, basically like Hasser, big collection of things. And then you're looking for the needle in that high stack, right? So even if the needle gets bigger, as long as, the high stack actually gets huge and huge, your task is actually even more difficult, right? So I think that's actually a very good metaphor in terms of, what we used to have, which is in a very arid land, a very small stack of hay for your cattle. Now you have mountains of hay actually that, you don't know what to do with, right? And then from that to get the most nutritious part or most useful part is actually the challenge that we're facing. So I say actually in my talks and with my colleagues and my students, the era of big data is actually a double-edged sword, right? It's a bonanza because more information is always kind of the music to the ear of a statistician, but at the same time it comes with responsibility, right? Because more information doesn't necessarily mean more meaningful information as long as you don't know what to do with it, right? So big data in a sense is actually the explosion in terms of volume and dimensionality of the amount of information that we're getting. And we're collecting it every second, every microsecond, actually, whether we know it or not.
Well, I think it's a perfect description when you say big data could be double-edged sword, and I think everybody would understand in what sense you're saying that, because earlier you said that data is being collected at an enormous scale from certain parts of the world, but not from others. But that the systems being built and the decisions being made based on that data is inevitably going to be applied universally. What are the mechanisms available to minimize that risk?
I think, the first step is, of course, acknowledging that that could be a problem, right? That's not a given. We actually had a workshop in Geneva, actually. It was funded by the Brochure Foundation from Switzerland last year. And the whole, topic was about epistemic justice in data science, and especially in relation to Africa. So as part of that, we're actually making literature review and trying to write some papers, again, in the context of Africa, even though it could apply to the global south. So I think awareness is very, very important. And then once you're aware of that, then what are the solutions? Of course, the most useful solution would be to really minimize the data gap. So in other words, to collect information. That is easier said than done, especially for historical purposes, but even prospectively in the future. And the other solution is to try to come up with tools that try to correct for the imbalances in data. So when you try to extract information, when you try to analyze the data, you have to use tools that acknowledge that, discrepancy, and try to make or to try to arrive at the right conclusion when there is mismatch in the availability of data. Now, the science has really advanced in that aspect, actually, but more needs to be done, especially in the context of the global south. For the last 4 or 5 years, there has been a big undertaking by the National Institute of Health in the United States, actually, to fund what they call Data Science Initiative for Africa. And to the credit of NIH, actually, spent like almost close to $80 million funding about 38 different projects across Africa. A few of them were research hubs. I was actually, so science advisory panel chair for one of them in South Africa, but including Cote d'Ivoire and Zimbabwe and South Africa as well. I'm leading, in fact, even currently it's ongoing, a training grant for Ethiopia and Kenya, Addis Ababa University and the University of Nairobi. And the whole point there is actually to train, create capacity around all these issues that we talked about. Issue of algorithmic fairness, epistemic justice, but really enabling the scientists, especially the young scientists, with these new tools, so that when they collect information and when they try to make sense of the information, they're actually aware of all these issues, but they're also equipped with the tools on how to deal with them. So across these projects, now the landscape in data science actually is quite different compared to the last 4 years, for instance. We meet like every year, and the transformation has been incredible. So to me, that's the more kind of sustainable and lasting solution, because if you have the know-how, if you have the skilled workforce that are aware, but in the right context, because they live there, they grew in the African context. They will understand the underlying issues, where the fault lines are. So now when they have the tools and the know-how, they will actually be best positioned to really make sense of, both in terms of the collection of information, but also in making sense of it.
To get you back to your area of expertise, Kiros, what is then the role of statistical analysis in making sense of big data?
Yeah. So the role of a statistician is to really be the quantitative scientist of any given team. Like, so for instance, when it comes to biostatistics, usually you work in a team science environment. So, as a statistician, you probably will be the only person in the room on how to know how to design a study and how to analyze and how to make sure that data is collected properly. But the process doesn't start there. There has to be a scientific question, and most of the time that comes from the domain area scientist. It could be someone who is an expert on asthma in children, or it could be someone who is an expert in cancer, someone who's an expert in kidney function, when workers are working in very extreme heat information. So there is what we call this biomedical model, or a conceptual framework, which is driven by the subject matter, knowledge. So the role of the statistician is to actually translate that conceptual or biological framework into a mathematical framework. So in other words, you take the pieces, first of all, biological frameworks are very complex. There is no way you can actually collect any data to answer all the questions. So, but once you translate that into a mathematical framework, then you can actually determine, which are the most important questions and what kind of information does someone need to collect in order to answer that question. Even though you're not answering the whole question, you're actually answering part of the framework, but by being aware of the other parts of the framework, so that you're not really working in isolation. So the role of the statistician is to make that translation into a mathematical framework, and from that to find out what kind of design would help answer that question. Like, for instance, if you're trying to see how growing in a polluted environment, this is one of my areas, so I'll give you an example. If a child actually is born or even conceived in a polluted environment and grows in that environment, compared to someone who grew in a very clean environment where there is very little pollution, or someone grows in the global north, someone grows in the global south, you can take it in any dimension. What kind of information, in what kind of frequency does the information needs to be collected in order to answer that question, right? So if I only collect one point of information, for instance, I'm not going to be able to answer what does growing up in a polluted environment mean like. So as a statistician, I'm going to tell the domain area scientist, first of all, you need to have repeated measurements. Second, you need to have enough number of individuals from the different localities. And third, you need to collect the information in enough frequency so that you will be able to answer or to characterize the growth trajectory of that child. So unless you do all that at the beginning, you could actually spend millions and millions of dollars, but at the end of the day, the information you collected may not be able to answer the question, right? So the role of the statistician is really to be what I call the quantitative scientist, which provides quantitative common sense into the scientific process, is actually how I kind of, explain the role of a statistician.
Wonderful. So far, we've discussed more or less in abstract terms statistics and big data and how they are applied, and epistemic justice and a lot of other interesting things. Maybe now take us to your little world of biostatistics then.
Yeah, I mean,
What
in a
is
way,
that?
in a way we have touched it, right? So biostatistics is essentially a branch of statistics that focuses on biomedical problems. I mean, that's probably the easiest, definition I can give. And when I say biomedical, maybe to make it a little bit more concrete and digestible, think of how communities are affected by what they experience in their lived experience, in their daily lives, how being exposed to some hazardous kind of factors impacts their outcome in health, and how long they live or the quality of life that they have, how their genetic makeup, who their mothers are, their fathers are, how that determines whether they are going to be at a higher risk or at a lower risk for certain diseases. So we know from experience, and maybe we don't need statistics for this, but the evidence came from statistics in one way or the other, or biostatistics for that matter, is, people that used to have or that had actually parents with diabetes are actually at a higher risk of developing diabetes compared to people that, do not have history of diabetes. That's why when you go to a doctor, they ask you for your family history, right? So that also feeds into the public health discourse. So in biostatistics, you basically try to take, all this, the totality of these exposures, whether it's your biological makeup, where you come from, or your lived experience, what we call nature or nurture in a way, right? The nurture is essentially, you can have, like, for instance, to give you an example, there are some what we call twin studies, twins that are identical twins, but for one reason or another, they grow up or they experience different things, in their life trajectory. So that's a perfect example that the nature part is taken care of, but the nurture part could actually impact in terms of how long they will live, their life expectancy, or how good their quality of life is going to be as they grow up. And then the role of biostatistics is essentially to really examine the data and try to tease out what are, what we call determinants of this trajectory of health, or where life ends and how life ends, at the end of the day, or how, our interaction with other individuals impacts us in terms of our health outcomes. So, so coming back to biostatistics in relation to public health, is essentially trying to work with other what we call domain area scientists or public health, skilled workforce, but the role is essentially to deal with the collection, analysis, and interpretation of the data, and then translate it in something that's actionable. Because at the end of the day, you can find something, then it has to inform the policymakers so that they can actually make enough change so that future generations are actually not impacted, or even current generations are actually somehow they find remedy. You can also go to what we call precision medicine, like in clinical practice. What you do in biostatistics could actually inform how a physician or a doctor counsels their patient, or what kind of prescription they actually provide, or how they monitor what we call prognosis, or in other words, progression of disease towards cure, hopefully, or at least towards better management. So, you can think of biostatistics essentially as a branch of statistics that really tries to inform public health or protect public health or health in general, basically.
Well, I think what you just said about biostatistics brings home the ramifications of what you spoke about earlier, the epistemic justice, because life or death decisions are being made on data that has been collected from certain places and from certain people. And I presume the temptation is to apply the result universal, as I said earlier. And I think everybody could immediately see the danger in that. Kind of the magnitude of the harm is bigger than it might appear at first sight. That's my understanding.
Absolutely.
I don't know if you would like to add something to that, but otherwise I was going to
No,
ask you.
right. Yeah, perfectly said. I cannot agree more.
All right. But also you mentioned you are interested in climate change as well. I think this is also something that a lot of people are interested in. So in what ways is statistics useful in the study of climate change?
Absolutely. Yeah, so I'm specifically interested in climate and health because climate change affects almost every aspect of life, right? If you, it affects, what the ecosystem is going to look like, what kind of crops will be grown in the future, what kind of disease, vector-borne disease especially will be the distribution globally, what it's going to be like, even to the point of actually predicting conflicts because there will be droughts, there will be floods, resources will be scarce or too much, and that will actually lead to conflicts. And then, health, of course. So, and the impact on health either could be direct because as heat, becomes extreme, people could actually die from extreme heat, right? Especially the young and the elderly, for instance. Actually, we are currently experiencing that both in Europe and here and everywhere else. So that's what we call direct, impact of heat, of extreme heat or other climate change induced, extremes. And then you have the indirect impact, right? So for instance, if we take sub-Saharan Africa, there has been poverty, there has been famine, there has been, malnutrition, stunting, you name it, for many, many decades and centuries. But with climate change, because traditional farmers may not realize actually the climate is changing and therefore they would follow centuries old tradition of the kind of crops that they grow, that could change completely due to climate change. And the gap that it needs for them to realize that things have changed could be a matter of life and death in terms of, the survival of the communities. Right. So that's, what is the indirect effect, because the lack of, nutritious foods and the lack of correct environments could actually initiate, health problems as opposed to the direct, extreme heat or extreme weather information. So I'm interested in those aspects. So again, as I said earlier, you have to understand the totality of the framework, and then you can focus on what you care the most or what you're skilled on, but without ignoring the other aspects, right? So the role of statistics is essentially, first of all, to translate that framework into something that's manageable mathematically or through modeling, and then to try to help in the collection of data in order to answer or to learn more about this. The other big thing about climate change, and especially in relation to health, is predicting what happens, 50 years from now, 100 years from now. All this issue about, the 2 degrees centigrade, increase in the next 20, 30 years or 50 years, and that leading to rise of, sea levels and, communities being submerged. All that is actually done through statistical modeling. And that's essentially based on scenarios, that may or may not happen in the future. And there is a big panel, what we call IPCC, Intergovernmental Panel on Climate Change, that creates like 5, 6 different scenarios. Under each scenario, it will predict, which part of the world will actually have increased temperature and impacts. Yeah. So in all these, statistics is part of it. So that's essentially, where my focus is and where our center at Columbia actually focuses on. 3 years ago, I was actually part of a panel called Future for Health and Economic Resilience in Africa. And it was trying to really look at health and economic resilience in general. It had like 14 working groups. Under that, there was one on environment and climate and health, but not only health. I was a member of that panel. It was from across Africa. And there was a working group on climate and environment. I was actually leading that working group. And we published about 3 or 4 papers now that essentially try to look at, first of all, coming up with this framework in its totality, and then try to kind of synthesize the evidence and making recommendations in terms of what needs to be done in relation to climate and health and pollution and health and food security and climate change, in the African context, actually. So in all that, again, statistics is everywhere, because at the end of the day, you will have to collect information and you will have to make sense of the information.
To take you further into the politics of climate change, Kiros, I think that the consensus is to say that there is no doubt climate change is happening. I think anybody who doubts that should explain why I'm sweating like a pig now, flip and joke aside. But I think where there is a bit of argument, I think from what I understand, is that they say that more than 90% of scientists agree that climate change is largely caused by human agency. And I think there are some scientists, credible scientists, who doubt that, right? That's my understanding, that although climate change is indeed happening, that it is not human caused to the extent that the mainstream understanding is. And when they go into the reasons why there is a disagreement, inevitably, I think it ends up being a discussion about the data, the quality of the data, how the models are constructed, and all that. Could you tell us a little bit about that, how the model is constructed, what is statistic there, what is data, who is collecting the data, and why there are certain scientists who have a bit of skepticism about the whole enterprise?
Well, that's a very, very big topic. It will take us like a day. So even then, we may not be able to make sense. I think part of the danger is when it comes to climate change, the term itself has been so politicized and it has become a polarized figure, right? So a lot of the people that are either, especially those against it, but even some that are for it in terms of, acknowledging climate change, um, you know, are driven really by either kind of, beliefs sets or biases or coming from a political angle. So I think I'm really gonna leave it at that for that, because as a scientist, I really have to base my conclusions on data. So let's put the polarizing role of politics aside, right? Because you will never get anywhere, right? But as scientists, I think, as you said, there is no question actually that our climate is changing, and then the issue is, of course, what is happening naturally and what's happening because of human activities. Again, the evidence is overwhelming in terms of that human activity has accelerated in a very, very drastic manner, what the climate is now. The whole issue about mitigation versus adaptation, in climate change actually is relevant here. What we call mitigation is essentially, can we stop the progression towards dangerous territories by modifying our behavior or human behavior. In other words, being careful, not polluting our environment, not doing damage to our planet, versus adaptation. To some extent, there are some that believe it's happening. So the real issue is about how we adapt to it as humans, how we survive it, and how we adapt to the new reality. I think the real reality is going to be in between. I think there will be need for adaptation because a lot of damage has already been done. And even if it's reversible eventually, hopefully, there will be a lot of damage and adjustment to be made in the meantime. So adaptation is real and necessary. The mitigation part is actually where most of the controversy is, because why do we change what we do? Because this is all kind of, fiction. It's not happening. And as you said, a lot of people question the data. But that kind of brings us to the issue about bad statistics and good statistics in a way, right? So, statistics and its very nature is about uncertainty. And there will always be some dose of uncertainty, which is healthy, that what we call as an answer is actually not absolute. It's always relative. And it's modifiable by data, by new information, right? But the totality of the evidence, either as synthesized by this intergovernmental panel for climate change, or even within Europe or the US, or even globally, in terms of predicting what's happening. I mean, as a scientist, I'm convinced actually that this is real, this is happening, and it has happened. The under the hood techniques are actually quite complicated because they have to take the totality of all information in a way actually that collects or synthesizes information that may not have the right or the similar structure from across the world, from many areas of science and many disciplines, many parts of the world, which, where the data is collected for different purposes and in different formats. So in order to take all that into account, the modeling scheme is actually quite complicated. And part of the complication comes from the fact that it needs to acknowledge all these fault lines in the way the information was collected. But at the end of the day, there is a famous saying that all models are wrong, but some are useful, right? We always are in the business of perfecting the, actually improving. I shouldn't say perfecting, but it will never be perfect, but improving our tools. And it has come a long way. So I think, where we are now, both in terms of our ability to collect information, but also in terms of our ability to synthesize and examine information, we're actually at a very, very sophisticated era. And climate science is actually using the most sophisticated and the best tools. So as a scientist, I'm convinced actually there is no doubt. But that said, there is a lot of work to be done as part of the scientific community to really translate what we understand as scientists in ways actually that are relatable to the public, in ways that are actually meaningful to the public. I think in many ways, actually, academia as a whole has failed or hasn't done enough in that aspect. Again, I don't want to digress in something completely different, but the last year or two in the US, actually, there has been a lot of activities in terms of questioning academia and questioning the scientific community. Some of it is actually from our own failure in terms of relating to the public in terms of what we do, which is why actually in a lot of things that I do, especially in environmental health, in all our undertakings, we always have aspect where we try to translate the scientific findings into what we call policy briefs or relatable kind of stories, even to the point of actually condensing it into a sentence, something that people could relate to. I don't know how we are doing with time. I'll give you one example. Before I came to Colombia, I was at the University of Southern California for about 22 years, and we had a very big study that followed like 12,000 children for many days, and 5 cohorts over 20 years, basically. Kind of spent like more than $100 million on that. There was a big findings there that said, if children grow in a polluted environment, their lung actually will grow at a slower rate. And if you translate that, take it to old age, there is a big chance that they will actually die prematurely because of that. Okay. So relating that and talking about all the sophisticated methods actually that we developed and applied may not be relatable to the public. In the end, there was one infographic actually that said bad air is equal to bad lungs, right? So this huge, scientific publication that was published in the New England Journal of Medicine, in the end, actually, I think that sentence really hammered, the message home, because if you have bad air, you'll end up with bad lungs. And then later on, we published a paper that said, as the air improved, children that grew up in the better air actually showed better lungs. That was actually a very powerful statement as well, because, in order to clean the air, you have to spend millions and even billions of dollars. The big question is this worth it? Are we just wasting resources for no significant benefit? As a scientist, you have to show, yes, once you do what you're supposed to do, you actually end up in a better place. So there is no stronger message than that in order to convince policymakers or to convince the public so that they force the policymakers to take action, right? So I think as a scientist, if you stop at your scientific publication, you're really not doing anything, right? You really have to go the extra step of relating to the public how that actually will make a difference.
On the issue of the reputation of science and the scientific method and research and scientists and all that, Kiros, that you say in the US, a lot of people have skepticism about it, and it's easy for politicians to convince people that the whole scientific enterprise is this suspect process. I think the reason is what I asked you earlier, which is that how do layman people tell whether the whole thing is being done correctly or not? Yeah. So that was the reason. I think that is a difficulty in explaining. So for instance, if bad data is being deliberately used and if conclusions are being drawn from that data,
right,
the non-experts have no way of knowing this is happening. And the politician could always come and say, this is how they are doing the science, and the science to the average person is a black box, and then people believe that. So how, in a way, my question was a bit philosophical as well. How do you deal with that problem?
I mean, you have to be relatable at the end of the day. You shouldn't take it for granted that science will speak for itself. I think, if it's related or conveyed in the right way, people will understand, we relate to it, right? So staying in the abstract always makes, things interpretable in many directions. Someone, either with lack of proper knowledge or with intent to actually disinform, will find it easier to use the abstract to tell their own narrative or their own story, right? I don't know whether I'm answering your question directly. So if I'm not answering it, ask me again. I think at the bottom of, at the end of the day, you really have to, not take, knowledge for granted, but really explain why you do what you do and why, what you do matters, to the bottom line, especially when you're not dealing with abstract science. Like if you are a mathematician, I mean, it's very abstract, right? If you do pure mathematics or pure computer science, it stays at the technical level, right? And you probably would not spend a lot of time trying to explain it to the public because there is layers of activities in order to reach the public. But if you are in field like public health or biostatistics, then you have to make it relatable because it could be done. There is no reason why it should stay in the abstract.
Mm. I think the takeaway point here is that it is incumbent upon the scientist or the researcher to make their work
Absolutely.
understandable and accessible to the general public, which is
Absolutely.
also what we are trying to do here with you, Kiros. Just one final point in terms of the relatively technical discussion. I think inevitably we have to talk about artificial intelligence, and people would be disappointed if we don't.
Absolutely.
What is the how statistical analysis and methods and models and all that related to the development of artificial intelligence?
That's the biggest question on everyone's mind, not only statistics. Actually, in our university, in our school, we are actually dealing heavily with this issue. We now have a new dean in my school, and we have a new university president. The biggest topic, actually, when people are asked, what are the most important questions that need to be tackled, is really the impact of artificial intelligence on many fronts, right? One is there is this fear on almost everyone's mind that AI will replace humans in many endeavors of employment. Robotics could actually be developed using AI to basically replace every facet of activity, human activity. Computer programmers are very worried because coding could actually be done, through agents, AI agents. So there is this big fear. And then that's one aspect, and I'll come back to that. The other aspect is even in the educational mission at universities. Now, you give assignments and you give exams. AI could do most of it, actually, right? So, it's very, very hard to tell where the answer is coming from, right? Is the student doing what they're supposed to do and answering and therefore gaining knowledge, or are they just relying on AI for them to do the assignment? So in the era of AI, how are assessments made? And, how do we judge whether people are getting the foundational or fundamental knowledge? And then the other thing is, we are in the business of training the next generation of scientists in any facets. Like in my case, it's going to be biostatisticians, data scientists, or public health scientists in my school. Are we really training them for the future? In other words, 10 years from now, what's the world going to look like? And therefore, our courses actually designed to teach them about last year or to teach them about what will happen 10 years from now. So we're actually, in my department, we are organizing a retreat to basically sit down and really think hard about, should we change the syllabus? Should we change the content of the courses? Should we design new courses? Should we stop teaching some aspects because we can easily tell them to ask AI to do it? But can we elevate the type of knowledge that we teach them so that they can leave, what we call mundane activities, to AI, right? So my metaphor is actually the same type of thought process actually happened when telephones were introduced. The same thought process happened when calculators were introduced. The same thing happened when, computers were introduced, right? So part of it is human nature. I think we always fear the new or the unknown, and therefore we always feel threatened. What makes AI different is actually it's a very different level of automation because it's actually designed to think like us, like humans, right? So that's actually what's the most scary part because it's a tool that actually learns, right? So this whole issue about whether AI tools or AI agents will actually form communities, and maybe at some point they may stop actually taking orders from us humans. It goes back to to the kind of philosophical or ethical issues about AI. Thinking about it now, and even when we develop the tools or the agents, if we do it in the way actually that has ethics in mind, then issues could be resolved. So I think that's essentially a lot of the thinking that's going on right now, not only in my university but everywhere, not only in universities but every facet of society. I don't see it as a threat, frankly. I see it as an opportunity, but it's an opportunity that we have to rise towards. And we could actually be better and probably think at a higher level, if we take advantage of this incredible tool that is, humans have developed in a way actually that could really transform how we do science, how we live, and how we progress as a species.
Just to expand on the point you make about the impact of artificial intelligence to the whole enterprise of teaching. From my own experience, for instance, in my college days, I would spend hours and hours trying to write a program that could, I don't know, do a simple task. It could be, for instance, sorting, I don't know, numbers in increasing or decreasing order. And it took me a lot of time to because on the boundary issues, there are a lot of things that you need to take care of. And the advantage of that whole thing was it sharpens your mind, your thinking. It's not just the programming, but also it develops your ability to think and to critically reason and all that. But now I could simply give Chat GPT a simple prompt, and all of a sudden the whole thing is in front of me. And not only is the artificial intelligence doing stuff for me, but also my brain is not at all engaged in the thinking process. And I think that has a blunting effect. And
Absolutely.
I know that because now, from time to time, to just make sure that I have my kind of programming abilities and all that intact, I try to write program, for instance, that adds to numbers, so simple thing. And all of a sudden, it's very difficult because I'm used to giving prompt to AI tools and getting the whole thing done. So I think the whole thing needs to be imagined. There is no doubt about that. Because the education system we have had so far was designed for a completely different environment, and with artificial intelligence, the whole thing has been rendered useless from my own personal experience as well. Just if you could take a bit of a detour into your own journey, Kiros. I know we're taking more time than you had bargained for, but I hope
I'm
you'll
enjoying
make it.
it. Take as
All
much as
right.
long as you want.
Oh, that's good to hear. I think, there will be a lot of young people listening to us and saying to themselves, this is a brilliant man. This is the kind of researcher that I want to be when I grow up and all that. And they will want to understand what are the things they need to know, what are the journeys that they need to make. And I think it's only fair that we say something in their interest. And I would just like to ask you, journey, where did the whole thing began?
Okay, good. Yeah. So across the world, uh, so my journey started. I actually grew up in Asmara in what is now Eritrea, and my parents hail from Aksum, and so my childhood, essentially is like every Habesha child in a way, surrounded with love, and I come from relatively good family in terms of so I had good upbringing, but I from the very early stage, I was very interested in academics. I think, with humility, I can say that I was a really good student and really interested in
It shows. It shows. So yeah.
and I was always interested in science. We may come back to this later on, but I was actually interested in knowledge in general. In fact, in some sense, even though science, math, but anything that relates to natural science was always my focus academically. I still have, and I always had, diverse interests: history, literature, all any type of knowledge. And again, of course, I'm sure you relate to this as well. Growing up, we, grow up surrounded civil war. Growing up in Asmara, I think the first few years until kind of almost midway to elementary school, it was a Haile Selassie era, but a lot of activities going on, especially in Eritrea, where I grew up, with disturbances, civil unrest and things like that. And then the Derg era came. So I think the formative years of my life and my high school years and university years all were under the Derg. But even though we were concentrating on studies, hearing gunshots or kind of hearing about people dying and things like that was commonplace. So that actually did not impact my academic journey much, because I was kind of on the young side when a lot of things were happening, and then I went to the university. But it actually teaches you in terms of surviving under a lot of things going on around you. So in a way, actually, it allows you to develop the knack for kind of focusing on what you really care about by zoning out other activities. Otherwise you wouldn't be able to do things that you would like to do. So in my high school years, again, I focused on natural science for the most part, and I chose the natural science stream. In fact, there is a very interesting story. I don't know whether I ever told anyone this actually, so I'm telling you a secret, in a secret in a
It's
way.
got exclusive.
Yeah. So, usually, I don't know whether it was like that in your time, but when you reach 10th grade, when you go to 11th grade, you go either to natural science or to social science or to commerce. And usually they try to assign by the kind of grades that you get. So my natural science grades were always good, but so were my history and geography grades and things like that. So, but I didn't want to inadvertently, because my grades were good in history and geography, to be assigned to art. So I actually deliberately lowered my grades, in history and the kind of the subjects that I didn't want. Maybe it was paranoia on my part, but I think I really wanted to go to the natural science stream. And then, on the side, I was very, very active in arts, kind of, acting in plays, writing poetry, writing short stories. But that was kind of on the hobby side in a way, even though I was equally serious about it. And then, of course, matric or SLC came. On the natural science stream as well. So I took 7 subjects. I got A's in all of them. So I could have actually gone to medicine or engineering, which is what everyone's dream is. If you are in natural science, you want to go to either one of them. You go to others only if you cannot do it. I know a few people that actually wanted to do pure science, but it was very, very unusual. In my case, I never wanted to be a clinician, but I also did not like engineering. So it was a big dilemma, right? That's where everyone wants to go to, but that the two things that I didn't want to go to. But I loved mathematics, but I didn't want to do pure mathematics. So it was a big actually dilemma in terms of what to choose. So I chose Arat Kilo for natural science, but I didn't choose medicine. I didn't choose engineering. And then by law of elimination, in a way, actually I ended up in statistics. At first, I thought maybe I would go to pharmacy, because eventually I wanted to go to biochemistry, because it was kind of, intriguing. But if you know anything about pharmacy in the Ethiopian educational system, you most likely end up in a pharmacy somewhere in a hospital. The route to going to higher education may or may not happen unless you stay in the university and they retain, which was a possibility, but not a guaranteed possibility. So I chose statistics as my first choice when I was actually selecting departments. I chose mathematics as my second choice for logical sequence. And then I left the other 4 blank, basically. I didn't choose anything else. Our cohort was actually very interesting. For the first time in the history, probably, of the Department of Statistics at Addis Ababa University, many of us actually selected it as first choice. I don't know how that happened. I'm telling you my story, but I'm sure others have similar stories as well. So our cohort was actually very, very strong. But that's actually how I ended up in statistics. And it turned out to be actually probably the best choice I could have made, because I'm always curious by nature. I love mathematics, but not in the pure sense for mathematics' sake. So statistics actually became a science that is almost a perfect fit for me without knowing it. I cannot profess actually that I did it for that reason, but I discovered actually it was the right choice in the end. Now, my foray to biostatistics was almost kind of an accident as well, because I wanted to do actually what we call econometrics, which is economic application of statistics. That's actually what I wanted to do. So in final year at Addis Ababa University, you do a final year project in our department. So I was going to choose econometrics, but there was one lecturer that we really liked that taught us probability, and he was doing his PhD, and he was doing it in demography, which is a study of populations. So he actually invited me to do my final year project in demography with him. Because I liked him, I said yes. So I ended up doing it in demography. So that actually was what triggered my interest in life sciences. And again, I didn't have anything, negative about medicine. The only thing I didn't like was clinical medicine. But if I grew up in the US, for instance, this is for our young listeners who may be in Europe or in the United States, being a physician scientist, someone who does like a medical degree but a PhD in some other basic science, would have been ideal for me. I would have chosen that. The only thing I opposed to was the clinical medicine part, seeing patients and things like that. So in a way, by going to biostatistics and by kind of immersing myself in environmental health and cancer and other many other health aspects, in some sense, actually, I came back full circle to come to health or public health, but from the mathematical angle, right? So that journey, some of it planned because I knew actually what to avoid because I was not interested in it. But some of it just by luck. Actually, I ended up in biostatistics. And now thinking back, if I were aware of the opportunities and the possibilities, I think I would have made the same choice actually. So in that sense, actually, I'm very lucky.
Well, interesting. In a way, you came full circle because you're telling me that you were as interested and as good in the humanities, in the social sciences as well, in geography and history and all that. And in a way, now what you're doing is kind of the intersection between all these things. So that in itself is fascinating. That
Absolutely.
you have carved out a niche that has all the things that used to interest you from younger days.
Absolutely.
Um, Oh, and you mentioned Haile Selassie regime and the Derg regime, and one thing that I hear a lot of people from that time say is that whatever else you might say about them, but at least the quality of education wasn't bad. I don't know if you'd like to reflect on that, but that is something that I hear a lot.
Well, I mean, I didn't benefit from the Haile Selassie era because, university students at that time, because, they grew up with, good command of the English language and they were, for the most part, actually taught, by either expatriates or people actually. So the number of students were smaller. So the student to faculty ratio was actually also very small. So the quality of education was actually higher, but very few people were actually getting that chance. My, educational era would be defined by the Derg era in a way. And I think there actually, the quality was okay, but access was limited, right? But for the most part, actually, if you think of the people that succeeded during that era, a lot of it is self-motivation and probably getting the right role model in terms of, very good teachers or very good mentors in a way. In that sense, I would give less credit to the educational system and more credit actually to motivated teachers and self-motivated students in a way. So, again, as you know, maybe 100, 120,000 people take, ASLC. There was only one university at first, Addis Ababa University, and then Asmara University was there, and then Alamaya became a university, so there were three. But in totality, between college and universities, whether diploma or degree, I think the intake was at most 10,000. And out of that, maybe 2 or 3,000 were going to degree granting college. And when it comes to medicine, it's only like 40 or 50, maybe 100. And then, of course, Jimma, Gondar, and others came because they split from Addis Ababa University. So part of the quality of the students was because you're really getting like a very, very small percentage of students that were kind of at the top of their game in order to go to universities. Now, one thing that probably deteriorated from what I hear, but based on my experience at university, is this unwholesomeness of education because courses were very, very loaded. The syllabus and the number of courses per student was heavy. Didn't leave room actually to any kind of scientific or knowledge inquiry by the students. You're trained to be a good, engineer, or you're trained to be a good statistician. You're trained to memorize, formulas and things like that. But the system never trained you to think and never allowed you to actually the room or even the motivation to actually have all-around knowledge. Very few people read outside of their subject matter area when I was in university. I used to be like a very voracious reader of fiction. I love novels, especially classic novels. In Arat Kilo, I can count by my hand, one hand, maybe two, if I'm generous, the number of people that actually read, seriously. Because books were scarce, most of us knew each other and we're exchanging books. So I think, that by itself was actually a big, shortcoming because you have people that got their degrees, they know their technical field, but if you ask them about, anything outside of their area, they're probably even less clueless, more clueless or less, informed than the average citizen. Sometimes even less so because they were so bagged with their own studies, they never looked up and looked at their society. Right. So in that sense, actually, I think, there is a lot lacking. And in fact, I don't know whether we'll come to that. I think, I trace most of the problems that we have now in terms of our outlook and our universal orientation and really listening to others outside of our area, and also maybe even having a meaningful and respectful discourse among ourselves to that lack of actually all-aroundedness. The other thing is, maybe this is a bigger topic as well, is the whole structure of education in our society. Definitely in Ethiopia as a whole, but I think it might translate to other parts of Africa or other parts of the world as well. The education, or so-called modern education, is not anchored in the context of our society, right? So you go to school, to modern school, you're actually almost being trained to be a day one skilled workforce for North America or Europe, not for your local society. Because, what you learn about, when we were in elementary school, there was a book of geography that told us a lot about Latin America, about, Amazon, indigenous people lived, or, about people in Asia lived, but didn't tell us anything about our surrounding, about our society, right? The same thing for history. We talk about Homer and other and things like that. No one told you about Zorayako, for instance, right? Unless you go and learn about it. So I think there was a disconnect that probably the whole modern education system actually failed to address when things were introduced in the very beginning, right? So, we talked about the Haile Selassie area, maybe not necessarily, as an individual, but when education was introduced, I think it abandoned the local knowledge base and it basically jumped into westernizing or equipping us, all of us, in Western education at the detriment of actually not knowing our society. So the more you know, actually, the less you know about your people and the more disconnected you become from your society, right? So again, I'm taking you in a very abstract and philosophical direction, but that's how I feel about our education, actually. I don't know,
Yeah, but that's very relevant and interesting, Kiros, because I didn't want to take you into the situation in Ethiopia and Tigray and all that. I wanted to focus on your academic journey and all that. But one thing that you hear people say, because you make the point that modern education hasn't given people the right tools to think and to be of good use to society and to really connect and more to produce organic knowledge and all that. One thing that you hear common people say is that the educated class and the elites of Tigray, for instance, if we just focus on Tigray,
absolutely.
haven't really contributed to the extent that one might have expected in terms of providing sense of direction and in terms of providing solutions to the serious problems Tigray is facing now. And I wonder how much of that you attribute to the deficiency of modern education.
I mean, it has a good share because people think that they are educated, and because they have the degrees, people give them respect and they give them credence, they listen to them, but they're not equipped actually to be the leaders, both in terms of their outlook, but also in terms of what they know. But, they haven't done, really, all of us. I mean, I shouldn't say they, I think it's all of us. We haven't done our homework to understand our people. We were given the mandate by our fathers and parents, mothers, and our communities. And a lot of them actually sacrificed a lot. A farmer would actually send, their child to the city, giving them, resources to be fed by relatives or even renting homes. That's not because they were wealthy, but they thought modern education would actually take, their children places. But it was actually also an assignment. Go out, understand the world, and really come back and change us and come back, change our society, be the next generation leader. I think in that sense, actually, we must have failed our society because I listen to all the discourse, sometimes I catch myself in terms of the way I think. I don't think we have done our communities service in a way in trying to understand them, not really dictate to them on things that we haven't taken the time to understand, right? So I think, in that sense, the elite has failed it, but it's not only the education part, right? It's also kind of the lack of courage, to take action and to take responsibility and to call, things, when they are wrong and to suggest solutions. In order to suggest solution, you have to understand the problem properly. I don't think most of us actually takes the time to understand the problems in their proper context. Most of the time, we ourselves are actually have not distanced ourselves from kind of the narrowness that's inherent and natural let's say, to our parents, because all they know is their village or their city, right? We have had the privilege of actually knowing the world and working in this, world-class institutions or world-class companies. And yet we work there, and then when we go home, we basically take off that, professional, kind of, cloak, and we basically go back to our village or to our very, very narrow kind of, settings. I mean, to me, actually, that's a disgrace and a disservice to our society. I think we have failed as elite. I mean, there is no other way to put it.
A related problem that has become more pronounced lately amidst what Tigray is going through is the inability of the supposed intellectuals. I'm not trying to be derogatory, but you understand what I'm saying. Supposed their inability to see things outside partisan lines, inability to think independently and to say something that might offend everybody, and lacking in courage. Really, that again, I'm probably putting you on the corner here because I didn't tell you I was going to ask you about these things. But how do you reflect about this very serious problem as far as I'm concerned?
Yeah, I mean, it goes back to what I said, probably in a little abstract sense, actually, the lack of courage in terms of, and kind of almost laziness in a way, intellectual laziness in a way, because like when it comes to Tigray, I mean, let's talk about it because, it's very relevant and we owe it, to our society. I think, it needs almost focus in terms of thinking about what's really good for the people of Tigray as opposed to any partisan interests. And then it also needs, clarity in terms of the purpose. What exactly is important? Is it the future of any political group, or is it really the future of the society of Tigray in general, right? So once you have clarity of purpose, and then you have the lack of laziness to take the time to understand the issues and also to try to take advantage of your global outlook, because we all of us are actually outside of Tigray. We are not really in the thick of things. So we have the privilege and the ability to actually think objectively. But in order to be able to do that, we have to free ourselves from the shackles of being afraid to either, to be someone or to get in the toes of someone else. I think that's actually where the biggest problem is. First of all, we don't take the time to understand the problem. Second, we don't try to analyze, to identify where the problems are. And third, we're not courageous enough to take actions. Of course, what we can do could be very limited from outside, short of actually being active in politics. But even in terms of the support we give, the credence we give, and even the way we voice ourselves needs to come with kind of, the core interest of Tigray in mind, as opposed to being shackled by, our own, inadequacies, or also fear of kind of being on the toes of someone, basically, right? So, I mean, if you want me to be a little bit more explicit, I'd be happy to. But I think that's probably,
Please. Yeah.
I mean, I mean, you have to ask me. But I think this is probably as far as I will go from my own. But if you have anything that you want me to be explicit on, I'd be happy to. Yeah.
Well, I think we'll draw a line at that today because
Yeah.
in the interest of time. But I feel like we've touched on a lot of important subjects. I think we have given our viewers a sense of what you are interested in, the topic that you find fascinating, and all that. But I feel like it should come back soon so that we could zero in on one of the topics you mentioned and discuss
Absolutely.
in detail. But just one more kind of departing thought. Earlier, you mentioned that you are interested in art as well, and indeed, I have read some of your Tigrinya poetry. If there is something in hand, or if off the top of your head that you remember that you could treat our viewers, that would be wonderful. Otherwise, we're going to wrap it up there.
No, absolutely, absolutely, yeah, yeah. So I think because our interview is in English, I'll probably try to stay in that language. But as you know, I'm equally active and very interested in literature. In fact, one thing we didn't talk about, and I kind of passed it, in the interest of time, when I was going from high school to university, one of the biggest decision-making point for me was, should I study literature or should I study science? I mean, it was that serious at that point, actually, because I was very, very active. I made a conscious decision not to do literature. First, because of my love for science, but second, during the Derg era at that time, censorship was very, very rampant. It was actually the time when people like, Balu Girma and others were actually, I think I was in university at that time when that happened. A lot of people were actually, either they have to write something that they don't believe in, or they can write something that they believe in and be hunted for it. So in that kind of environment, maybe having literature as my field may not be the right environment. If I grow up here, actually, in the US, it's possible actually that I may have gone the other direction. So because of that, I came back to literature after maybe 18 years. So I stopped writing deliberately in 1982 and I went to Addis Ababa University because I cannot do both. But I kind of transitioned to reading a lot and watching plays instead of acting in them and reading instead of writing. It's only after I came to Los Angeles in 2020, 1998 into 2020, that for some reason I started to write again. So I kind of, kept that active. And I had a website called Muscat for many, many years before the era of social media that I posted my poems on, but I also posted poems from others. And then, of course, with Facebook and X and Instagram now, I started posting more and more poems. And in fact, 2 years ago, I published my first book of Tigrinya poems, Kiros Berhane. So I'll find a way to get you a copy, actually. It hasn't reached Europe yet. So.
Yeah, but you can hold it up properly to the camera so people could see the title at least.
Right.
Yep. Wonderful.
Yeah, so it has about 60 poems. One third of them were actually written during the Tigray conflict from 2021, and they are all about the conflict. So in that sense, actually, it almost had a therapeutic effect for me. I write when I'm feeling really conflicted or troubled by something or inspired by something, as any poetry is, of course. So it has been a very, very active and more now, actually. But as of 2 years ago, I actually started translating classic English poems into Tigrinya. And now I'm actually thinking of publishing a book of translations. And the sole purpose is to make, classic poetry of English from centuries. Some of them are by Rumi, some of them are by Tagore, Omar Khayyam, it goes back, or I even have one by Pushkin, for instance. And then, the famous poems like Langston Hughes, Robert Frost, all this. I try to stay with those that are in the public domain so that I can publish them, but really some of them go centuries, 200-300 years. So maybe I should read one that is written by, maybe I'll read two. So, and they're short ones. Both are by Langston Hughes. One of them, actually, I took the one by Langston Hughes, I translated it to Grinya, but then I wrote another poem that's inspired by that poem, but it has actually in relation to our mothers. And Tigray was on my mind when I was actually doing that. So this poem by Langston Hughes says, "Quiet girl." So very short, like 6 lines. I would liken you to a night without stars, were it not for your eyes. I would liken you to a sleep without dreams, were it not for your songs. This is what Langston Hughes wrote. And then what I wrote is, it says, "Wounded mother." I would liken you to a land overflowing with rivers, were it not for the salt in your tears. I would liken you to a sleep snug in the clouds, were it not for your silent sobs. So this was essentially, kind of almost, ከምዚ ምስ ቋንቋን ንኖታትና ማለት እዩ ንዴታትና ማለት እዩ and is also kind of classic again by Langston Hughes. It's called Harlem. Langston Hughes was one of the Harlem Renaissance poets, African American poets. Harlem is, by the way, in New York, where I live. We are just about 1 mile away from it when we talk now. And sometimes the poem is called Dreams Deferred. And this is talking about the African American experience, but again, it also relates to Tigray in a way, in terms of dreams deferred. So this one says Harlem, or dreams deferred. What happens to a dream deferred? Does it dry up like a raisin in the sun? or fester like a sore and then run? Does it stink like rotten meat, or crust and sugar over like a syrupy sweet? Maybe it just sucks like a heavy load, or does it explode? It's a very, very powerful poem, and I translate this into Tigrinya actually. So let me read this at Tigrinya one. ወይስ ይረክስ ቆሲሉ መግሊ ኣኸቲሉ ይጨንውዶ ከም ስጋ ዝበስበሰ ወይስ ተሰንኪቱ ይነቅጽ ከም ነታዒ ዝፈሰሰ ምናልባት ይቁርብዕ ይኾን ሓሚሙ ከቢድዎ ስኽሙ ወይስ ይመልእ እሞ ይፍንድእ Yeah. I mean, it relates because I try to contextualize it. And again, I have loved this poem for many, many years, but it really resonated to me actually. When I was thinking about the current situation that we are in terms of dreams of our people, dreams of our children. Again, I don't want to prolong the interview, but I have been going back to Tigray many, many times for the last 25 years. And you pass, from, let's say, you're going from Magale to Aksum or anywhere place, you meet, children, school-age children. What really lightens the mood was actually the thirst for knowledge they have, the curiosity that they had. And if you have done it, those trips, no child actually asks you for money, which was surprising. I was with American colleagues at a time. We were driving from Magale to Aksum, visiting schools, by the way. And then we met children. All of them were asking for a pencil or a pen. And my American colleagues actually commented on that, right? So it was that level of curiosity, that level of hope, actually, that you were seeing in the small children. And I was actually thinking about them in the last 3 years, those actually have grown and they became youngsters. And those are the same people actually that were fighting in the conflict. So think about dreams deferred, and think about, dreams squashed. So the power of poetry is actually that it kind of heals you, but also it speaks through centuries and generations because the human experience is actually very common. And unfortunately, we tend to repeat history. We tend to live history over and over again. And therefore, what was written 1,000 years ago might relate to what we experience, as humans now. So that's actually why I love poetry, because, to me, it was actually a therapy, in the last 4 or 5 years. But, and I love sharing it because I think, it actually has allowed for interaction with like-minded people. So anyway, so that's my other side, apart from the science. So I'm glad you brought it up, actually.
Yeah. And it's depressing and poignant to think that those children you talk about have been denied that basic opportunity that should otherwise have been their natural right.
Absolutely.
It will always be a source of eternal pain for me, and I think for many people that has been allowed to happen. And thank you for the poems, Kiros. That was a wonderful treat to our viewers as well. We should end it here, but I feel like even on the poetry aspect, maybe I should get a copy of your book and invite you on another time.
I'll get you one, yeah, of course.
Absolutely. But thank you very much for today.
Of course. Really a pleasure, and I really enjoyed our discussion, and really thank you for everything that you do. I've been following you, and it's a great service. Keep it up, and happy to help in any way in your activities.
That was my pleasure. That was Professor Kiros Berhane, everybody. Thank you for listening to us. Bye-bye.